Hi, Janet. I'd love to answer this question for us. So, what you need to do is to calculate the change in the enthalpy in 3 steps. You need to calculate it from increasing the temperature from the starting point to the melting or the fusion point. You also need to calculate the latent heat of fusion, which occurs at the melting point. And finally, you need to calculate the heat associated with increasing the temperature from the melting or the fusion point to the final temperature. So the ideas actually come from the caloric theory of heat, which is where we get the calorie as a measure of energy. So to start us off, I've written all of our equations on these 2 boards. So as you can see, the first part, what we're trying to calculate is the amount of heat that is added to our system as the temperature rises in the solid form. So as the temperature rises while it's a solid, we are transferring energy from the surroundings into the system. The system is, of course, substance X. Presumably, we're transferring the energy to substance X by way of heat. So it's important to realize that heat is an energy transfer process, which is to say that nothing in the universe contains heat. Heat is simply a way to transfer energy from one form or from one substance into another. And this is something that's described by the zeroth law of thermodynamics. So as we are transferring energy from our surroundings to our solid substance X, the molecules that make up substance X begin vibrating about an equilibrium point with greater kinetic energy. And due to the increase in kinetic energy, the temperature rises. So once we get to the point where we have a fusion point or a melting point, the energy that we transfer no longer increases the kinetic energy of vibrations. As a result, the temperature at a phase change does not increase. So this explains the flat lines where the slope is 0 that you see in items 2 and 4. Instead, the energy transferred at the melting point contributes to weakening the intermolecular forces that are holding substance X together as a solid. And the weakening of these forces is responsible for forming a liquid. It's responsible for melting the solid. Once we have sufficiently melted substance X into a liquid, the energy transferred once again goes to increasing the molecular vibrations of a liquid. Consequently, we observe the increase in temperature. So what I have for us here are the calculations that you would need to do. The first calculation is just the Q is equal to MCAT equation. So we just plug in the mass that we have. We were given the specific heat, and we would also include the temperature change. We calculate 378 joules of energy. So this is the energy it takes to raise the temperature from -2 to the melting point of 5. So once we're there, we calculate how much energy does it take to weaken the intermolecular forces that we spoke about, so that way we can melt this solid into a liquid. And here you'd be given a constant. We were told it was 100 joules per gram, so we went ahead and calculated that as well. Finally, we do a very similar calculation in the third step as what we did in the first step. So the only difference really is that we have a different specific heat value and we have a different temperature change, but it's still the same 27.1 grams of substance X. And so we calculate that. And finally, all we need to do is just sum these values up, and we have the amount of energy that's required in order to increase the temperature and account for the phase shift. So I hope this was clear. I hope the video helps, and good luck in the future.